In today's video, we're going to learn how do we solve combination circuit. When we say combination, that means the circuit has both series part and also parallel part. Okay, now let's get started. So if we have something circuit looks like this. So we have one resistor here, another resistor here, another branch, resistors. So I say it's the E, it's the R1, R2, R3, R4. And it's the E, and the current for this guy is IT. So what is given is kind of what it's given IT equal to 1 amps, R1 equal to 325 ohms, R2 equals 275 ohms, R3 equals 150 ohms, R4 equals 250 ohms. Now let's solve the circuit. So we need to find the current for R1, R2, and also the current for R3, R4. Then we need to find the power for them, P1, P2, P3, P4. Also the voltage for each other, V1, V2, V3, V4. So what is given is here. By looking at this, so in order to find E, we also need to find E here. In order to find E, we need to get RT first. So in the circuit, R1 and R2 in series, R3 and R4 in series. Then they in parallel. Then they in parallel. Okay, so for series resistance, it's R1 plus R2. Then parallel with R3 plus R4. So let's do this. R1 plus R2 is 325 ohms plus 275 ohms, which will give us 600 ohms. R3 plus R4 is 150 ohms plus 250 ohms, which is 400 ohms. And then the in parallel. For the parallel part is 1 over 600 ohms plus 1 over 400 ohms. That will give us 1 over, so 600 times 400, 600 plus 400 ohms. So that will be 24,100 divided by 1,000. That's 2.4. So that's 240 ohms. That's RT. Basically, the formula for RT is 1 over R1 plus R2 plus 1 over R3 plus R4. Equals 1 over 325 ohms plus 275 ohms plus 1 over 150 ohms plus 250 ohms. then equals 1 over 1 over 600 ohms plus 1 over 400 ohms. Then it will be 600 times 400, 400 plus 600. 1 over. Then it will be 24,0000 divided by 1,000. So it will be 240 ohms. That's how we solve for RT. That's RT here. After we get RT, we can get an E, which is E equals IT times RT equals 1 amps times 240 ohms equals 240 watts. After we get the voltage, we can get the current for R1, R2 since they in series. That will be E I1 equal to E divided by R1 plus R2 equals 240 volts divided by 325 ohms plus 275 ohms. 240 volts divided by 600 ohm equals 0.4 amps. That's the current for R1, R2. So V1 equals, if we use Ohm's law, I1 times R1 equals 0.4 amps times 325 ohms, which means so if we use the calculator, we can get this number 130 watts. V2 equals I1 times R2, or we can also use E minus V1, which is 240 minus 130. If we use this, it will be 0.4 amps times 275 ohms. It's the same thing, maybe. It's the same thing. We should get 110 volts here, so that's 0.4 times 275. It is 110 volts. There are different formulas after we get, V1, V2. Same thing for 3R4, 3R4. We get I2 equals E divided by R3 plus R4 equals 240 volts divided by 150 ohms plus 250 ohms, which is 240 volts divided by 400 ohms, which is 0.6 amps. After we get the current for R3 and R4, we can get V3 equals I2 times R3 equals 0.6 amps times 150 ohms, which is 0.6 times 150 will give us 90 watts. So for V4, we can use I2 times R4. We can also use the E minus V3 equals 0.6 amps times 250 ohms, which is 0.6 times 250, 150 watts. If we use this guy, it's 240 volts minus 90 volts. It's also 150. It's also 150 here. And for the power P1, we can use E, or sorry. So for P1, we can use V1 times I1. That would be V1 is, what do we get here, 130 times 0.4 amps, which will be 130 times 0.4, 52 watts. For P2, same thing, V2 times I1. Because R1 and R2 in series, so the current same for both R1 and R2. So V2 is 110 volts times 0.4 amps equals 110 times 0.4 is 44 watts. For R3, P3 equals V3 times I2. V3 is 90 watts times 0.6 amps equals 90 times 0.6, 54 watts. For R4, the power P4 equals V4 times I2. Same thing, R3 and R4 in series. So that would be 150 watts times 0.6 amps equals 90 watts. And for the total power, we can use P1 plus P2 plus P3 plus P4. We can also use E times IT. We also have IT squared times R. So either formula will work, or E squared over RT. So the number will be 52 watts plus 44 watts plus 54 watts plus 90 watts. Total will be 52 plus 44 plus 54 plus 90 will give us 240 watts. If you want to prove this number by using this formula here, which is IT is 1 amps. So it will be 1 amp squared times RT. So here's RT. RT is 240 ohms. So that's 240 watts. So basically for the series circuit, the current are the same on that branch. Let's say if we have a resistor in series with another one, R1, R2, R3. So all the current flow are the same on this branch because there's only one way that the current can flow. So current are the same everywhere. They all kind of the I, but the voltage are different. Because they have a different resistance. If they have the same number, if let's say R2 equal to R1 equal to R2 equal to R3, that will give us the same voltage. V1 equal to V2 equal to V3. Other than that, then V1 and V2, V3 are different. So for the parallel circuit, the voltage are the same. For each resistor. Let's say if we have something like this, R1, R2, R3. So the voltage across this point, if we put a voltmeter here, they will have the same reading across R2, R3, and R1 because they are equal to the voltage here. Basically, this is just one line. There's no voltage drop on these lines. but the current flow are kind of different because, let's say, the current will be I1 equal to V divided by R1, I2 will be V divided by R2, I3 will be V divided by R3, unless they have the same resistance. That will give us the same current. If they have different resistance, that will give us different current. So if we remember that, and let's look at another example. If we have something very complicated, so let's say if we have something, there's one resistor here, another resistor, so here we have R1, R2, R3, R4, R5. Let's label this is R5, this is R6, R7, R8, R9. And we have the power source E. So let's say we have a non-resistors parallel or combination circuit. They have parallel part and series part. So basically, by looking at this circuit, we need to find the start point. Where do we start? So usually we start from, kind of a series part, then in parallel with this guy, just step by step how we simplify the circuit. Just try to group the resistors. So then this guy, this part, this whole part here. All right, let's just do it step by step here. So step 1, we can do the resistance for R3 and R4 because they're in series. Let's name it RA equal R3 plus R4. Okay, first let's give all the resistance values for the resistors. So R1 equals 450 ohms, R2 equals 280, R3 equals 175, R4 equals 225, R5 is 220, R6 is 1200, R7 is 1100, R8 is 1300, R9 is 150, and E is 240 watts. So by looking at the combination circuit, we need to find the total resistance first. That's the goal for us. We need to do the total resistance. So start with R3, R4. That will give us R3 plus R4. R3 is 175 ohms plus 225. So that will give us 400 ohms. Then R3 and R4 in parallel with R6. Let's name it RB. That will be RA. That's a combination of R3 and R4 in parallel with R6. That's step 2. So that will be 1 over 400 ohms plus 1 over R6 is 1200. If we use a calculator, we can get this number. So 400 plus 1200, 400 times 1200 ohms. That'd be 4800, 1600. So that's 300 ohms. So that's RB. Basically, it's this part. We get this part now. Then RB is in series with R2 and R5. So in order to get that part, it's RB plus. So that will be our step 3. RB and R2, R5 in series. So let's say it's RC equals RB. For series resistance, it's RB plus R2 plus R5. RB is 300 ohms. RB is 300 ohms plus R2 is 280. R5 is 220. So the total is 800 ohms. So that's RC. After we solve RC, basically it's kind of this part. It's everything on the top here. And then RC is parallel with R7 and R8. We can put them together. Let's say this is step 4. RC is parallel with R7 and R8 in series. So basically we need to do the series part first. So let's name it RD. That's 1 over RC in parallel with R7 and R8 in series. That will give us 1 over RC is 800. That's what we get from before. Plus, once the R7 and R8 are given, so R7 is 1100, R8 is 1300. So 1100 plus 1300. That will give us 1 over 800 ohms plus, let's do this part, 1 over 2400 ohms. So it will be 2400 times 800 ohms divided by 24 plus 800. So 24 times 8 is 192.0000 divided by 3200. That would be 600 ohms. So that's our RD. RD is kind of everything here. Let's see everything here. So this is RA. This is RB. Everything on the top is our RC. So this part will be our RD. After we get RD, there are only two resistors left. So that's R1, RD, R9 in series. We have step 5. So step 5 will be R1, RD, and R9 in series. So that will be our RT equals R1 plus RD plus R9. That will give us R1 is 450. 450 ohms plus 600 ohms plus R9 is, that's 150 ohms. So the total will be 1200. After we get RT, we can get the current, total current IT equal to E divided by RT equals 240 volts divided by 1200, 2 amps. So that's the total current. After we get the total current, we can solve the voltage drop for R1. It will be, since R1 is on the main branch, its current is IT. So it's 0.2 amps times R1, which is 450 ohms, will give us 90 volts. Same thing, R9 is also on the main branch. So V9 also equal to R9 times IT equals 0.2 amps times 150 ohms, which is 30 volts. After we get the voltage for R1 and R9, we can get, so basically we have something like this right now. This is R1, this is RD, this is R9, and this is E. So we get the voltage drop for R1, voltage drop for R9, then we can get the voltage for VD. Let's name it VD equals E minus V1 minus V9 equals 240 volts minus 90 volts minus 30 volts, which is 120 volts. VD basically is the part here, everything on the top there. So basically this part is RD. That's our RD. So the voltage for this part is VD. So this is R2, this is R3, R4, R5, R6, R7, and R8. Then we do the, after we get VD, we can get the current flow this branch, and also the current flow this. So the current for R7 and R8 will be VD divided by, let's name it I7. VD divided by R7 plus R8, which is VD is 120 volts divided by R7 is 1100 ohms plus 1300. That will give us 120 divided by 2400. So it would be 0.05 amps. After we get the current for R7 and R8, we can get the voltage for resistor 7 and resistor 8. V7 will be R7 times I7 equals 0.05 amps times 1100 ohms, which is 55 volts. And V8 will be R8 times I7, since they're in series 0.05 amps times 1300 ohms, 65 volts. And after that, we can get the power for 7 equal to V7 times I7, 55 volts times 0.05 amps. 2.75 watts. P8 will be V8 times I7. V8 is 65 volts times 0.05 amps equals 3.25 watts. Now we get the bottom part. Just need to look at this part now. So we get a VD. If we use VD, so the resistance is this R2. This is R3, R4, R5, R6. So the total resistance for this part is what we just get. So that will be our RC. That will be our RC. R2, R5 in RB. RB is the parallel part on the top. So this is RA. RB is here. This is RA, which is R3, R4. I just write down RA for R3, R4. RB is for the part R3, R4 in parallel with R6. That's our RB. RC is R2 in series with RB and in series with R5. So we're looking at RC right now. RC is 800 ohms, so we're gonna use RC. So the total resistance for this part is RC, which is 800 ohms, and the voltage is VD. So the total current for this part, let's say I2 equals VD divided by RC. VD is 120 volts divided by RC 800 ohms. That's 0.15 amps. And after we get I2, we can get a voltage drop for R2. V2 equals I2 times R2 equals 0.15 amps times R2 is 280 ohms. So 0.05 times 280, 42 volts. Same thing, we can get the voltage drop for R5, which is I2 times R5. So that would be 0.15 amps times R5 is 220. That's 33 volts. After we get the voltage drop for, so this would be V5. After we get a voltage drop for resistor 2 and resistor 5, we can get the voltage for this part. So let's say it's VC will be VD minus V2 minus V5. That will be the voltage for this part. So that will be VC. After subtract the resistor here, R2 and R5. So we have R3, R4, R6. So that would be VD is 112. So VD is 112 volts minus 42 volts minus 33 volts. That will give us 120 minus 42 minus 33 equals 45 volts. So that's VC. Basically, that's a voltage across this part. R3, R4 in parallel with R6. That's our. Let's go back. We already saw that part. R3, R4 is RA in parallel with R6. So that's our RB. RB is 300. So RB is 300 ohms. Now we can get the current flow R3, R4, and R6. So let's say I6 equals VC divided by R6 equals 6. This is B. VC is 45 volts divided by R6. So 45 divided by R6. R6 is 1200. That will give us 45 divided by 1200. 0.0375. That'll be the current there. And we're going to get a V6 equals. So V6 basically is a VC. It's a 45 volts. And the current for R3 and R4 will be, let's say, I3 equals VC divided by R3 plus R4. This is our RA. So it'll be 45 volts divided by 400 ohms. That will give us 45 divided by 400, 0.1125. And voltage for R3, V3 equals I3 times R3 equals 0.1125 amps times R3 is 175 ohms. 19.6875 volts. And V4 equals I3 times R4, since they in series, 0.1125 amps times 225 ohms. So 0.1125 times 225, that will be 25.3125 watts. And for the power, P3 equals I3 times V3 equals 19.6875 volts times 0.1125 amps. 19.6875 times 0.1125. That's 2.2 watts. P4 equals I3 times V4 equals 0.1125 amps times V4 3.3125 volts equals 0.1125 times 25.0125, 2.8 watts. So at this point, we kind of already solved for everything. We get all the information. We have all the current we need. At this point. So basically the idea is we start at the, if we look at the circuit itself, resistor here, if we look at the circuit itself, we always need to start from some point. We try to simplify the circuit, so we try to group the resistors together. So we start from here, Z2 together first. This is our RA. Then after we get RA, we calculate the parallel part for this one. This is our RB. Then RB in series with this guy and this guy. That's our RC. So this will be our RC. Then we can do this together, or we can separate it. This is our RC. Then we can do the whole parallel part here. So the whole parallel part is this guy here. That's our RD. After we get RD, the circuit is kind of simplified, like just like this. This is our R1, RD, and R9. Then we can get the total current. After we get the total current, we can get the voltage drop for V1, voltage drop for V9. Then we can get the voltage for VD. After we get that, we can go back to that circuit. It's just we have to go forward first, then we need to go backward in order to get the current. we get the current to help us to find the voltage drop across each part. After we get the voltage, we get the current. And we get the current, we can get the power. So the idea is RT, then we get IT, then voltage for each part. Then we get a current for each branch. After we get the current for each branch, we get a voltage drop. For each resistor on that branch. Then we get the current. So we already have the current, so we get the voltage for the rest. So that's kind of the idea how we solve the combination circuit, especially for the very complex ones. Alright, I hope you guys learned something from this video. Alright, I hope you guys learned something from this video. I will see you guys next time.